Okay, good morning, guys. So this is the start of a new part in chapter 4, which is called Force System Resultants. In this part, we will learn how to simplify our system force into a force resultant with a moment or force resultant on some points on this body. So basically in this part it is about the simplification of the force and the couple system, and we will take a lot of cases, special cases, and we will study how to simplify such systems. So let's start. Assume that I have this example right here where I have a lot of forces on a body with an external moment. So basically, guys, any external moment is also a free vector. Free vector means I can put this moment in any point on this body because basically this is the result of a couple force. So as we described in the previous video, if a couple of forces is a free vector, which means that the effect of this couple moment is the same for all the points on this body. So basically this moment is an external moment caused by a certain couple moment, so I can put it whatever I want, and I have some forces F1, F2, F3, F4, and these forces are applied on some points on this body. So my objective here is to simplify this force system into more let's say a compact force system composed of a force with a moment or of a force alone, so that the effect of this compact or the simplified force system is the same as this one. In other words, if these forces here will cause a certain translation, then my resultant force in the simplified version will cause the same effect in translation. If the system here caused some rotation, my resultant system will cause the same rotation as this one. So this is the objective of this part, and let's start by the first step, which is to find the resultant forces. So basically I can find the resultant forces of all these forces. That will be, of course, in vector. F resultant is equal to the sum of all these forces, F1 plus F2 plus F3 plus F4. Now, if the resultant of these forces is located at O, so if I take this resultant and I put it on O, then, guys, I will have the same translational effect. However, I will not have the same rotational effect. So why I'm saying this? Because in fact, all these forces will have a certain resultant. And this resultant force will cause a certain translation. Meanwhile, all these forces will have a certain rotational effect. So they will cause some rotation to this body around O. So if I put these forces as one resultant force located at O, I am cancelling out the effect of rotation. Because in fact, I'm putting this F resultant on O. And I know that if F resultant passes through O, this means that there is no moment. I know from the previous part that the moment is equal to 0 if the force that is causing this moment is passing through the point of rotation. So this means, guys, that I cannot put this F resultant on O unless I put a resultant moment. So unless this F resultant is accompanied by a moment resultant. So I will repeat, guys. These forces will cause some rotation, okay, around O. So if I put F resultant on O, this means, guys, that I'm cancelling out this moment. I'm cancelling out the rotation, because if the force is passing through the point of rotation, this means that the moment should be equal to 0. And this is not our case. The moment here is not equal to 0, which means I have to put this F resultant on O accompanied by a moment resultant that is equal to the moment of all these forces plus what? Plus this external moment, if any. So if I have any external moment, I should add it to M resultant of the moments of all these forces. So basically, F resultant should be accompanied by M resultant that is equal to the sum of all the moments around O, of all the moments of all the forces, of course, around O, plus any external moment caused by any couple of forces. So this is how to make the simplification of these forces and the external moments and the moment caused by these forces around point O. So as you can see here, guys, I have at O F resultant and M resultant, and don't forget M resultant will be equal to the sum of all the moments plus the sum of all the external moments that could be caused by a couple of forces. Now, in order to understand this step, let's do this problem, very easy problem. So now you should do it by yourself. You should not have any problem in finding M resultant, because we have 4 different methods and you can apply any of them. Now this is a 2D case, so I will apply the methods applied in 2D case, although I can apply the vectorial method or I can apply the SMART method as you want. You can try it by yourself and you will find that you will have the same answer. Okay, so let's start by this problem here. Now in this problem, let's first increase the size of the figure and hide the solution. So basically, guys, here I have 3 forces. So I will call this one F1. So let's say this is F1. I will call this F2. And I will call this one F3. Okay. Guys, I want you now to focus on the question. So basically, the question, any change in the question will change my answer. So what is the question now? The question is to replace the force and couple system by an equivalent resultant force and couple moment acting on O. So this is the question basically. It is to replace the force and couple system by certain resultant system on O. So I should know, guys, where is the point that I need to put my force resultant and my M resultant. So here my point is on O. So basically the steps is, of course, to find first F resultant in vector form, to put it on O, and then to find M resultant and to put it on O. What is F resultant? Since this is a 2D case, I will start by FRX. FRX will be, of course, F1x plus F2x plus F3x. Now, what is F1x? F1x is, of course, 3 cosine 30 plus F2x is 5 times 3 over 5. It is also positive plus 0. So this is FRX. Now, what is FRY? FRY is basically 3 sine 30 minus F2 because it is in the negative side, 4 over 5 minus 4 Newton. So this is F4x and FRY. Now I should find F resultant. Now what is F resultant? Basically F resultant is FRXI plus FRYJ. Now FRXI is equal to what? FRXI is equal to 5.5 and FRY is equal to minus 6.5. Okay, so basically FR will be equal to 5.5I minus 6.5J, and of course guys, in order to locate FR on O and to draw it, I should find its magnitude and its direction. So its magnitude will be as a square root of what? So it is square root of 5.5 squared plus 6.5 squared, and its direction theta, let's say with x, of course I should draw this theta, let's say it is with x, will be 10 minus 1 of what? Of FR y, that is equal to 6.5 over FRX, that is equal to 5.5. So of course I can find all I can find the magnitude and the direction. So basically the magnitude is equal to 8.58 and its direction is defined by this angle 49.3. Okay, so guys, let's go to this figure here and let's draw our F resultant. So our F resultant is defined by an angle that is equal to 49.3 from X. So let's say this is X. So this is, for example, 49.3. Okay, and this force has a magnitude of 8.58, and don't forget that it has a negative y component. So basically, this will be F resultant. So this is F resultant. This is theta. Okay, and this is F result. This is the first resultant component, which is the force